Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students, and it's good to see all of you again. So we are now in lecture 2 of 3 in the same subtopic of 3.1 sequences and series. So without wasting so much time, let's take a look at the definition and the formula that involved with this topic and subtopic. Find the n term of geometric sequence and series with n term of a times r to the power of n minus 1 and use the sum of the formula of this. Okay, so previous we look into the we call definition of arithmetic sequences and series. So now we look at a new one here with geometric sequences and series. And this formula, the n term and also the summation until n term is the one that we're going to use mostly in this topic. Okay, so since that R is a ratio, so R cannot be equal to 1 because 1 minus 1 equal to 0. So is the denominator equal to 0. So the whole things or the whole function is undefined. Okay. So geometric sequence is a sequence of numbers in which term can be obtained from the previous term by multiplying by a constant number called the common ratio. So with your notes handout with you right now, so please to refer to the handouts too. Okay, let A be the first term and R be the common ratio. So A times R squared, A times R cubed. So the first term, which is A, the second term, the third term, the fourth term. Okay, so generally we can say that the summation until n term of the geometric sequence is A times R to the power of n minus 1 here. Okay, the n term is the common ratio, which is R equal to, okay, common ratio, the n term, here we call, can be multiplied or divide by the previous of n minus 1 term. For example, t2 divided by t1, the second term divided by the first term, the third term divided by second term, and so on until we come up with a general of the n term divided by n minus 1 term. Okay, given a sequence of 3, negative 16, 12, and negative 24, find the n term, the 9th term, and the k term. Okay, so first of all, given a sequence of them, the first term, which is 3, the second term, negative 6, the third term equal to 12, and the fourth term equal to negative 24. So find the n term for this one, where a equal to, which is a equal to the first term equal to 3, and r equal to the second term divided by the first term, which is negative 6 divided by 3 and equal to negative 2. So find the n term equal to a r to the power of n minus 1, where a equal to 3 and r equal to negative 2 to the power of n minus 1. There you go. Okay, this is the one. And then the ninth term, t9 equal to a equal to 3 and negative 2, 9 minus 1, when n equal to 9, so 9 minus 1 equal to an 8. And guess what t9 equal to? Yes, 7, 6, 8. In this case, you may straightly use your calculator. Okay, and then what about k term when given that tk equal to 192? So 3 and negative 2 power of k minus 1 equal to 192. So then negative 2 power of k minus 1 equal to 192 divided by 3 equal to 64. And for this case, you may use the log or whatever, but then I just thinking of, let's say we come up with negative 2 to the power of 6. Negative 2 to the power of 6 and negative 2 to the power of k minus 1. So you can see here now the base are equal now. So we can ignore, we just focusing on the index, which is k minus 1 equal to 6, then k equal to 7. There you go. Okay, the nth term of the sequences of the nth term sequence of Tn equal to 5 times 3 over 2, where r equal to 3 over 2 times power of n minus 1. Show the sequence is a geometric sequence. Find the value of n where Tn equal to that one. Okay, so for this one here now, let's find out where r equal to Tn divided by t of n minus 1. Okay, so Tn equal to 5 power times 3 over 2 to the power of n minus 1 divided by 5 to the power of 3 over 2 to the power of n minus 1 term. So just imagine that if this n, we substitute with n minus 1, n minus 1, n minus 1. So 5 divided by 5. Okay, now the basic are equal. In this case, please try to refresh what we've been taught in chapter 1. Okay, a to the power of n divided by a to the power of n equal to, good, a to the power of n minus n. So then 3 over 2 and 3 over 2 is base equal in here. So 3 over 2 to the power of n minus 1 here, n minus 2, n minus 2. Okay, so 3 over 2 to the power of n minus 1 minus n plus 2. N minus n, 2 minus 1 equal to 1, then it is equal to 3 over 2. Okay, so therefore, okay, there's a constant of 3 over 2 here. So we come up with a conclusion that therefore the sequence is a geometric sequence. Okay, that's the solution for question of A. Now find the value of n where Tn equal to, okay, let's find that. Okay, so now for question of B, okay, so for the question of B, which is 5 to the power of 3 over 2 to the power of n minus 1 equal to 1215 divided by 32. Okay, earlier given that the Tn equals to 5 power of 3 over 2 to the power of n minus 1. Okay, so now let's say divide by 5 left and right. So they become 3 over 2 to the power of n minus 1 equal to 1215 divided by 5. It gives you 243 divided by 32. Okay, And again, for this question, they create a question that until a stage that you can relate this with a base of 3 and this one with a base of 2. So just imagine that 2 for 3, which is 3 to the power of 5, you just write. And then 32 equal to 2 to the power of 5. So 3 over 2 to the power of 5. And we compare with this one here, 3 over 2 to the power of n minus 1. And again, the basic are equal here right now. So we're just focusing on the index where n minus 1 equal to 5. So then n equal to 6. Sorry. Okay, n equal to 6. Okay, are you still with me? Okay, good. Now, the sum of geometric series, okay, given that as a summation of the nth term, given that as an equation 1 and multiply equation 1 by r, and okay, so you can see that here. Okay, I think that you understood what I'm trying to say because you have your handout with you right now, so you could just compare the notes with this one here. Actually, it's exactly the same. Okay, and then given the summation of equation 1 and equation 2, so now make it as an equation 1 minus equation 2. So it means that here we may compare the term in equation 1, we have a r and also a r. We have a times r square and a times r square. A multiplied with r cube, a multiplied with r cube, and so on. You can see that here, okay, cancelling between the we call the pairing of every single term. And what if we see here that's right now? There's only two terms left, which is a and also a times r to the power of n. There you go, a and ar to the power of n. So then summation until n term equal to a times r1 minus r to the power of n divided by 1 minus r. Okay, now the first term of geometric sequence is 27 and the common ratio is 4 over 3. Find the sum of the first 5 terms. So we are trying to extract all the information given that the first term of geometric sequence is 27 and the common ratio of r equal to 4 over 3. So now, given that where a equal to 27 and r equal to 4 over 3. So the summation of the first 5 terms, okay, so then S5 equal to 27 times 1 minus 4 over 3 to the power of 5 and then divide by 1 minus 4 over 3. Okay, you may still recall, find out the solution step by step with this one here, 1 minus 4 over 3, until you get it, the answers of this, which is 781 divided by 3. Okay, now the next one. And now let's find out the solution of question B. Find the least number of terms of the sequence that can have if the sum exceeds or more than 515. Okay. Okay, so now with the b then here, okay, so Sn is greater than 550. So with 27 times 1 minus 4 over 3 to the power of n divided by 1 minus 4 over 3, which is greater than 550. Okay, so 27 bring up here, divide by 550, divide by 27, and 1 minus 4 over 3, or 3 over 3 minus 4, it becomes negative. So bring to the side, it will change the direction of this, and it come up with 1 minus 4 over 3 to the power of n, which is less than negative 550 divided by 81. And okay, it's not it, this one here. Okay, and then 4 over 3 to the power of n, it gives you 631 divided by 81, and then using the logs rule and bring to the side, it becomes n log 4 over 3 and greater than log of 631 divided by 81, and then divide n, and with the log of this divide by everything here, it gives you 7.136. So then therefore the least number of terms is 8. Okay, so when given the log of 4 over 3 is greater than 0. Okay, the hint given that log 4 over 3 is greater than 0. Okay, sum to infinity of a geometric series. So the summation to infinity geometric series is given that sum of infinity and then we call modulus of r, which is less than 1, where given that r lies in between negative 1 and 1, as an n approach to infinity, r to the power of n approach to 0. Okay, so this is the one that we are going to use to find the summation until sum to infinity. So example 4, find the sum to infinity for the series of this. So now, given that the first term, which is equal to 3, and r equal to the second term divided by the first term, which is a second term here is 1, and the first term is 3, so 1 over 3. So, what's next? We use the formula of S infinity, which is A divided by 1 minus R, and A equal to 3 divided by 1 minus R, where R is 1 over 3, then it is equal to 9 over 2. The sum to infinity of a geometric series is 7, and the sum of the first two terms is 48 over 7. The sum to infinity. Find the common ratio, positive common ratio, and the corresponding first term. So, with information given here, the sum to infinity of geometric series is 7. So then, S infinity equal to 7. This is the first information that we can get from the questions. And the sum of the first two terms, S2 equal to 48 over 7. Okay, now find the first positive common ratio. Positive common ratio, which is R is greater than 0 or positive. So A divided by 1 minus R equal to 7, and this one is S2, which is A plus AR equal to 48 divided by 7, and factorize this. A1 plus R equal to 48 over 7. So this is equation 1 and this is equation 2. Okay, class. I think that I can make some adjustment here. From this, A divided by 1 minus R equal to 7. I'm going to make this one as an A equal to 7. Bring up here 1 minus R. Okay, there's an equation 1. Why? Okay, I have this A, 7 times 1 minus R, and this also A multiplied with 1 plus R equal to 48 over 7, meaning I'm going to substitute this statement of A into this A, okay, equation 1, substitute into an equation 2, 7, 1 minus R, okay, A equal to 7, 1 minus R, multiplied with 1 plus R equal to 48 divided by 7. So what's next? Okay, from here, divide by 7 left and right. So divide by 7, 7 divided by 7 equal to 1. 48 over 7 divided by 7, it seems like it's just like a 48 over 7 multiplied with 1 over 7. And then expand this, it gives you 1 minus R squared equal to 48 over 49. 48 over 49. So then try to simplify this, it gives you R equal to plus minus 1 over 7. Okay, so we have two values of R, but then we wanted the positive common ratio. So with this the answers that we learned here in positive, meaning we are only looking for the value of R, which is 1 over 7. And then what's next? So then the value of A equal to A equal to 7, which is R, and then 1 minus 1 over 7 equal to 6. Okay, next. Stating a repeated decimal numbers in the simplest fractional form. Okay, example 6. Express the following recurrent decimal as an infinity geometric series and state as a fraction in the simplest form. Okay, guys. This one means it is a 0.484848 and so on. It's endless. And what about this one here right now? It seems like it is a 0.235 3, 5, and 3, 5. 3 and 5 repeated again and again, endless. So, how express the following recurrent decimal in a infinite geometry series? And let's find it now. Okay, so for solution of A, so then the question of A, which is 0.48 bar, which is 0.484848, and look at this one here. This, the first one is 0.48 plus with 0.0048 plus with 0.000000, another two zeros, 48, and so on. Okay, so now what can you see here now is a pattern of numbers 0.48 and 48 here, right? Okay, now this is an infinite geometric series with A is 0.48 and R equal to 0.0048, the second term divided by first term 0.48, and this gives you 1 over 100. Since that R, okay, since that R lies in between -1 and 1, the sum to infinite exists. Hence, okay, now 0.48 equal to A divided by 1 minus R, which is A equal to 0.48 divided by 1 minus R, which is 1 over 100. Okay, 0.48 bar here, and this one it gives you 16 divided by 33. Okay, you may test by yourself. Press the button of 16 divided by 33 and press the button of equal. It'll give you this kind of numbers with a pattern of 0.484848 and endless here. Okay, now for the solution of B, for solution of B, 0.235. Okay, so equal to 0.235, 35, and 35. It is now become 0.2 plus 0.035, 0.035 plus with 0.00035. Okay, so this is the pattern of infinite geometric series. Does not include with 0.2 here, so which is A equal to 0.035 and R equal to 0.00035 divided by 0.035, and this is going to give you 1 over 100. Okay, so now S infinity equal to A, which is A is 0.035, divided by 1 minus 1 over 100. And using your calculator, this is going to give you 7 divided by 198. Okay. And now 0.235 equal to 0.2 plus S infinity, which is 0.2 plus 7 over 198, and this one is something like 1 over 5. 1 over 5 equal to 0.2 plus 7 divided by 198 equal to 233 divided by 990. Okay, so I do hope that with my simple, slow explanation, we give you the clear, makes all of you clear with the solution of this. Now, okay, so job vacancy for 1 month. So job one, $1 million at the end of the month. Okay, job one, it offers you a salary of $1 million at the end of the month, 1 million, and 2 cents on the first day, 4 cents on the second day, 8 cents on the third day, and so on. So, okay, guys, girls, if I ask you honestly which job that you're gonna grab, without thinking without thinking deeply inside, without thinking for a long period of time, and of course, I do believe that all of you will grab for the job $1 million. Okay, but for job two, okay, what kind of job that gonna pay us 2 cents on the first day, 4 cents on the second day, 8 cents? You all disappeared. Okay, never mind. Job one and job two. Let's see by calculation which job that offers you more than, okay, is either job one or job two. Okay, which job will you choose? Okay, if I do believe that most of you will choose job one. Okay, let's see. Okay, with the job one here, okay, so for job one, okay, RM $1 million. Okay, right now with job two. Okay, job two, the summation. First day they give you 2 cents, and the second day is 4 cents. 4 cents is 2 squared, and then 2 cube, 8 cents. Okay, plus with until it is 2 to the power of n. Now it is a 2 and then 2 to the power of n minus 1 divided by 2 minus 1, sum to infinite. Okay, and then what about this one here? 2 minus 1 equal to 1. And of course, it's only 2 to the power of n minus 1 left here. So let's say until the 30th day of the month, 2 to the power of 30 minus 1. Class, find the answers using your own calculator. What will you get then? I think that all of you might say that this is such a we call crazy calculation or amount, where the first day is 2 cents, second day 4 cents, third day is 8 cents, and so on. And numbers that you get here is RM21, not 21,000. Please guess. 21,474,836. What? Okay, you have 1 million and now you got 21 million. So it's either job 1 or job 2. Okay, that one, you think by yourself for this solution of this job 1 and job 2. Okay, you might change your mind to grab a job 2. Okay, a lecture hall has a 50 rows of seats with the 30 seats in the first row, 32 in the second row, and the 34 in the third, and so on. Find the total number of seats. Okay, what about this one here now? The numbers of seats in the rows form of arithmetic progression. Okay, so class, just imagine that this is the pattern of the hall. Okay, your lecture hall, and this is the stage. So you are sitting in front of your lecturers here right now, and first row, it has 30 seats. Second row, it has 32 seats. The third row, 34 seats, and so on. 34, 36, 38, and until the 50th row. Okay, so now where T1 equal to 32, T2 equal to 34, T3 equal to 36, and so on, which I think that this is not a geometric, this is arithmetic sequence. Good. So then find the total number of seats. So S50 summation until 50th row, which is 50 divided by 2, and then 2a, which is a equal to, or the first row is 30, sorry, the first row is 30, this is 32, 34, and so on. So 30 plus n minus 1, where n equal to 50, 50 minus 1 is 49, and d equal to, so the difference between the second and the first row is 2, 32 minus 30. The difference between the third row, 34, with the previous, the T2 is 32. 34 minus 32 equal to 2. And the total of seats is 3950. Okay. So with example 8, Example 8 is I think that let all of you try by yourself and exercise. So, and the final answer is 17,433.92. Okay, that's all for today. Thank you very much. Thanks for your time. See you next again. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.